Rotational grazing of pastures has been practiced for many years. For centuries, shepherds have moved their flocks from one grazing area to another in order to provide better grass for those flocks. Today, most stockmen rotationally graze their livestock by moving from summer to winter pastures. But there's increasing interest in intensive rotational grazing. Much of this increase in interest is due to the advances in technology of electric fencing and watering systems, which make setting up intensive rotational grazing systems fairly simple. One of the more significant advances in electric fencing equipment has been the low-impedance or New Zealand-style energizers. These types of fencers have more shocking power and can carry a greater weed load than the old-style high-impedance electric fencers. This greater shocking power of the low-impedance energizers is due to the large currents produced, which are not as severely drained by vegetation or leaking insulators. The voltage output of both the high and low-impedance electric fencers are very similar, but the greater current of the low-impedance energizer makes the shock a much more memorable experience. There are three styles of energizers to choose from: battery, solar, and mainline. Battery energizers can be powered by D-cells, lantern batteries, or 12-volt automotive-type batteries. The more power produced by the energizer, the faster the batteries will drain and need to be replaced. Some of the largest battery-powered energizers may drain a 12-volt battery in 1 week. In order to avoid the constant switching and recharging of batteries, especially with the 12-volt systems, installing solar panels to keep the batteries charged is highly recommended. In order for a solar panel to do an adequate job of keeping a battery charged, it's important to fit the size of the solar panel to the size of the energizer. Manufacturers' recommendations regarding size and panel positioning should be followed when purchasing and using a solar battery charging unit. If possible, it's best to use a mainline energizer since you can get more power for your purchased dollar, and you don't have to worry about keeping a battery charged. Mainline energizers with high outputs are available and come in 110 or 220 volt styles. Operational costs of mainline energizers are minimal. Due to this low operational cost, low maintenance requirements, and lower purchase price, a mainline energizer should be your first choice if it'll work in your fencing system. Remember, it may be more economical to run a half mile of lead wire than it is to use a battery-powered energizer. Once you've decided on what style of energizer will work for your operation, you need to decide what size of energizer will be required. The first thing to do is to determine how many miles of actual hot wire will be hooked to the energizer. Also, keep in mind future fence expansions. It's better to spend a few extra dollars on a slightly larger energizer at the start than to have future expansion curtailed because your energizer is too small. Once you know the number of miles of hot wire that you'll have, you can start looking for an energizer that'll power your system. Comparing and selecting energizers can be a very confusing job. One way to simplify the process of comparing brands is to look at the joule ratings of the different energizers. A joule has an output of 1 watt per second. As a rule of thumb, 1 joule of output will electrify 1 mile of fence, even with significant weed pressure. A good grounding system is a must to ensure that your energizer will produce at its maximum potential. This is not the place to try and save a few dollars. An inadequate grounding system will reduce the shock potential of the fence, causing animals to barely flinch as they walk through it. To avoid this frustration, use an adequate amount of ground rod that is properly connected to the energizer. 3 feet of ground rod per joule of output is recommended. In some cases, it may be necessary to use more than 1 rod for adequate grounding. If at all possible, place the rods in a damp location such as the north side of a shed under a drip line. Manufactured ground rods can be either copper or galvanized steel. Galvanized pipe may also be used. The grounding rods, connecting wire, and clamps should all be of the same material. Do not mix galvanized steel and copper. Be sure the connecting wire is clamped tightly to the ground rods with the proper clamps in order to ensure a good connection. The ground rod should be fully driven into the ground and placed at least 10 feet apart and should be at least 25 feet away from the grounding system of the electrical company. To protect your investment, install a surge protector at the electrical outlet for mainline energizers to protect from electrical surges. If possible, avoid installing the energizer in areas prone to lightning strikes. To help protect against lightning strikes, a lightning choke followed by a lightning diverter should be installed in the lead-out wire between the energizer and the pasture fence. The lightning diverter, which acts as a spark gap, should be connected to a grounding system that's equal to or larger than the grounding system under the energizer. Be sure there's at least 10 feet between these two grounding systems. Many energizers are covered by company lightning warranties. Be sure to follow the company recommendations for lightning protection in order to validate the warranty. Once the energizer and its systems are installed, you need to decide what type of posts and wire you're going to use. This is where taking a few hours to do some planning and price comparing can save money. The number of wires used and the post spacing will depend on the type of animals being controlled and the roughness of the terrain. For internal fences, normally one wire will control cattle. Calves will require 2 wires if it's important to keep them in a particular paddock. Sheep will need 3 wires. Fences with 1 or 2 wires can normally be spaced at 40-foot intervals, but as more wires are added, this may drop to 25 feet. 8 wires are recommended for a predator-proof fence for sheep and goats. High-tensile wire is recommended for permanent fences, while polywire, polytape, netting, or maxi-shock is recommended for semi-permanent or temporary fences. Several different types of high-tensile wire with different gauges and strengths are available. The 12.5 gauge Class 3 galvanized wire is the most commonly used high-tensile wire. Wire with a high breaking strength is stiff and more difficult to handle, while wire with a low breaking strength is easier to handle but will tend to sag sooner after being strung. It's best to use crimping sleeves or twist links to splice wire or secure strands of wires at end posts. If the wire is placed in possible high-stress areas, it's advisable to use either 2 crimping sleeves or 2 twist links intertwined. Because high-tensile wire is difficult to control, a wire dispenser is almost a necessity when stringing wire. When purchasing high-tensile wire, it's best to get good quality galvanized wire, which will have a smooth, shiny surface. The zinc coating flakes off easier on poor quality galvanized wire, allowing it to rust sooner. In order to tighten high-tensile wire, it's necessary to use either an inline strainer in each strand of wire, or to tighten the wire with a wire stretcher and splice with crimping sleeves or twist links. These strainers or splices should be in each strand of wire or at quarter-mile intervals in long strands of wire. Tension springs should be placed in short stretches of fence that are less than 200 feet and in areas that will receive lots of animal pressure, such as lanes or watering areas. Polywire, polytape, netting, and maxi-shock are much easier to put up and take down than high-tensile wire and should only be hand-tightened. Over-tightening the polywire and polytape products may break the fine wire filaments that are threaded within the plastic part of the wire and carry the electrical current. It's important to test the poly products for current even though they appear physically fine. The poly products are highly visible to both animals and people, but they have a shorter life expectancy than maxi-shock or cable wire. The life expectancy of the poly products can be greatly increased if they are wound and stored on reels. Knots and kinks tend to break the wire filaments. The maxi-shock, on the other hand, has a longer lifespan, but it has low visibility, becoming a dull gray color when exposed to the elements. P-springs are available to help give the maxi-shock more break resistance when livestock or deer run into a strand of it. Barbed wire should not be used with low-impedance energizers. Sheep, calves, and children can become entangled by the barbs and shocked to death. There are a variety of types of posts that can be used with electric fence. The traditional wood and steel T-posts can be used as long as good insulators are used for the hot wires. Fiberglass and plastic posts are non-conductive, so wire clips may be used to hold the wire. These types of posts are a less expensive alternative to wood and steel posts for stretches of the fence that will not receive lots of up or downward pressure. The white fiberglass posts come in two sizes, 3/8 inch or 5/8 inch diameter, with metal clips to fit the different sizes. Another type of fiberglass post available is the sucker rod, which comes in 1 inch and 1 1/4 inch diameters. Galvanized cotter keys are used as clips on these posts. Electrical gates can be used to complete a paddock fencing system. Spring gates are versatile and can be easily used where there are different widths of openings. They probably should not be used in areas that will receive lots of animal pressure, though, as they can lose their elasticity if stretched too far when an animal attempts to run through them. A less expensive alternative that is more visible but less adjustable is the tape gate that you can construct yourself with a gate handle and a roll of polytape. It's best to set up a gate system so that the gate does not become electrified until it's closed. A hot gate laying on the ground snapping can excite livestock, making it difficult to move them. In permanent and semi-permanent fencing, gates should not be used to carry the current between sections of fence, since they do not make good contacts and power can be lost. It's best to bury insulated wire beneath the gate opening to connect the sections of fence. Scattering cutoff switches throughout an electric fence system at strategic spots, in combination with a voltmeter, can save lots of time and frustration in locating shorts in a system. If the voltage reading increases after disconnecting a cutoff switch, the short is in the part of the fence beyond that switch. Many other accessories that make installing and using electric fence systems easier are currently available, with new products becoming available all the time. Some of these systems may be worth the expense, depending on your specific operation. Although posts and wire are major parts of an intensive rotational grazing system, a watering system is also a big consideration. Lanes leading to watering sources are a possibility, but it's best to avoid excessive lane traffic whenever possible. Pinwheel designs where all the paddocks radiate out from a central water source are also a possibility, but it's not highly recommended due to the trampling and overgrazing of the parts of the paddocks close to the water source. The most efficient systems have water available in every paddock, so that animals spend more time grazing and evenly distributing manure and less time walking to and from water. Water may be delivered to paddocks through a pressurized system, a gravity flow system, or a naturally powered pump system. Using small tanks whenever possible allows for greater flexibility. Cost can be reduced by using small tanks that can be moved from paddock to paddock. It's important to remember, though, that a tank must be able to refill before the next animal comes up to drink, or the thirsty animals will become upset and can knock the tank over. The small tank systems work best with pressurized systems because of the rapid refill capabilities. Usually, gravity flow systems require larger tanks with some reserve capacity because of the slower refill rate. Pumps can be naturally powered by water, wind, the sun, or the animals themselves. These pumps work well if you have the proper power source available. Some of these pumps, such as the nose pump, are limited to frost-free weather, which limits the seasons they can be used. Watering systems used year-round in freezing environments must have their water supply pipe buried below the frost line. This feature limits the watering locations and adds to the initial cost of the system. If the watering system is used only during frost-free weather, the water pipe may be placed on top of the ground or in shallow trenches. Above-ground water pipe should be placed in the fence line to keep animals from walking on it and to allow some vegetation to grow over it. The vegetation will help keep the water cooler in hot, sunny weather. Pipe lying above ground or shallowly buried will need to be drained during freezing temperatures. Garden hose can be used to transport water from the permanent supply line to the tank. Always place water tanks partially beneath the electric fence in order to keep livestock from damaging the float. Every grazing system will require a watering system that is unique. It's best to consider several options and to price each alternative before you begin the installation.
On this system, in 4 paddocks, I have a nose pump incorporated on the paddocks that are above the pond. So when we bring them in here, they have a new group of cattle, which we have there every year. Probably takes a day or 2 for them to get used to it, but they figure it out fairly quickly.
The only thing that is permanent type fence is around the extreme perimeter around the roads. Everything else, the paddock division and the perimeter that borders other CRP is intensive electrical fence.